Hello guys, I wanted to make this video over the following example that is right here. So in this video we're going to do this example and we want to solve this rational inequality and state our solution in interval notation. So these can be very tricky depending on the inequality symbol. The best way to go about this is to know, I guess, to state the restrictions. So, number one, we want to state the restrictions, okay? So state, and what I mean by that is that we want to know where the where this cannot be defined. So looking at the denominator, we know that for this expression here, we cannot have x, so x cannot be equal to 5 and x cannot be equal to -8. The way that I did that was that basically you set x minus 5 not equal to 0, x plus 8 not equal to 0, and solve. So you get these two things, okay? And so then we also want to state our x-intercepts. And there's a reason for this, and it's because of the fact that this is an greater than or equal to symbol. So number 2, we want to state x-intercepts. So I'm going to go ahead and say x squared times x minus 11 times x plus 3 over, and it's x minus 5 times x plus 8 equals 0. So to solve for x, we want to go ahead and multiply both sides by x minus 5 times x plus 8, since we want to get rid of the denominator here. Okay, so doing that to both sides, we get x squared times x minus 11 times x plus 3 equals 0. And so using zero product property, we have x squared equals 0, x minus 11 equals 0, and x plus 3 equals 0. So then we do square root, right? We get x equals 0. And then do plus 11 here. Okay, we get x equals 11. And then do minus 3 on both sides here. And we get that x equals -3. Now, since these are my x-intercepts, we know that these will be included in the interval at which it's greater than or equal to 0. So we're definitely going to include those. Now, the next thing I'm going to do is I am going to make a number line. So I'm going to make a number line stating both my restrictions and my x-intercepts. So going in order, if I state my x values, I know that x equals negative. So we had x equals 5, x equals -8, x equals 0, x equals 11, and x equals -3. And then stating it in order, we have x equals -3. I'm sorry, x equals -8, excuse me. X equals -3, x equals 0, x equals 5, and x equals 11. Now we want to make sure we understand which of them are restrictions and which of them are the x-intercepts. Only 5 and -8 are the restrictions. So we want to make sure to say that. So these two parts will be my restrictions. Whereas the rest of these, and I know I'm kind of repeating myself here, but I'm trying to be very clear with this because it can get very tricky. So these are my x-intercepts. Now let's go ahead and make a number line. So if I do this, my number line is going to be the following, and I'm just going to do a random number line, and I'm going to go in order here. So I'm going to go in order. First was -8, so let's say here's -8. And then the next one was -3, so here's -3. The next one was at x equals 0, so here's x equals 0. And then the next one was x equals 5, so here's x equals 5. And then the next one was 11. So these are my 5 numbers. Now again, we want to know which ones are restrictions and which ones are x-intercepts. So the restrictions are at -8 and 5, so I'm going to go ahead and put open dots or open circles at -8 and at 5. And then I'm going to put closed circles or filled in dots because those are included in my interval, since the inequality states, you know, it's greater than or equal to 0. And like I said, when we made all of these equal to 0, the x values we got were these green ones. So we know that those will be included in the interval. So therefore, we're going to put closed dots here, here, and here. So I'm hoping that makes sense so far. And then the next thing we're going to do is we are going to go ahead and state my intervals. So from -infinity, and then here's infinity. We're going to go in order. So from -infinity to -8, and then comma, -8 to -3. And we know that because it's a filled in dot, as y'all can remember, if it's a filled in dot, this indicates a bracket. So that's why I'm putting a bracket there. You have to be good at knowing how to, like, you know, when it's brackets versus parentheses and a filled in dot versus an open dot. So, so we have that, and then we're going to go ahead and say comma, and it's going to be this part here. So from -3 to 0. And as you can see, these both have brackets. And then we know that then it's from 0 to 5, so bracket 0, comma 5. And it's a parentheses at 5 because we're not including it in our answer, since, like I said, those were my restrictions, or that's one of my restrictions. And then comma 5 to 11, and then comma 11 to infinity. We always put parentheses for infinity and -infinity. So now we want to test the first interval. And my first interval that I listed was from -infinity to -8. So here we have -infinity to -8, and we're going to go ahead and test that. And so doing this, let's go ahead and test an x value between -infinity and -8. So I'm going to choose, I'll choose -9. So let's go ahead and test x equals -9. So you want to test something that's less than -8. And when we do that, let's go ahead and grab our inequality here. And this is our original inequality. Let me go ahead and rewrite it here. Okay, so, excuse me. And we want to know where it's greater than or equal to 0. So doing this, we know that we're going to go ahead and state the following. And so we're going to go ahead and do it the following way. So if we do it for -9, we have -9, and goes like this: -9 squared times -9 minus 11 times -9 plus 3 over -9 minus 5 times -9 plus 8. And we want to know, is this greater than or equal to 0? So we have 81 times -20, I think, times -6 over -14 times -1. And as you can see, this is a positive over a positive. And if it's a positive number, that means it's greater than 0. So we know that it does satisfy the inequality. So so here we know that we want to go ahead and state that this is one of the solutions, or one of the intervals for the one of the intervals that's a solution, basically. So we know that that's a solution, and then we want to go ahead and do now between -8 and -3. So test the following from -8 to -3. Okay, so then if we do that, we get, again, it's going to be the following. And let me go ahead and test. So choose an x value between -8 and -3. We're going to choose x equals -4. So when this happens, I'm going to go ahead and write it down. I also want to state this is not a coordinate, okay? This is an interval. So do not confuse this as a coordinate. This is from interval A to B, where A is -8, B is -3. We're testing an interval here, a number between -8 and -3. So you want to make sure you understand the difference between an interval and a coordinate. This is not a coordinate. So we're just doing in terms of x, and we are not, so both of these values are x. This is from x1 to x2. Okay, and it's an interval, so I just want to make that clear. Now, again, we're testing it and seeing if this is greater than or equal to 0. So, so then if we do this, we get 16 times, and it's -4 minus 11, so that's going to be about -15 times -1 over, and it's going to be -9 times 4, excuse me. And we know that this is, so it's greater than or equal to 0. And we know that if we do this, we get a positive number up here. So really this is positive. We don't really have to know what it is, as long as we know it's positive, and then only for greater than or equal to 0, right? We only have to know if it's positive on the top, and then it's over a negative. So we know that the answer will be negative. So therefore, this is not greater than or equal to 0. So the interval from -8 to -3 cannot work. Okay, so we know that my interval from -8 to -3 cannot work for this part. So far, the only one that's working is -infinity to -8. So we're just going to shade that there. And then, and then now we're going to do from -3 to infinity. I'm sorry, -3 to 0, excuse me. So, so when I do this, so now we want to do from -3 to 0. And we're going to test x equals, and let's do, we want to do a number between, okay? So you just want to make sure, I want to make that very clear, that we're doing a number between those two. So let's test x equals -3. I'm going to do -1. So when I do that, and actually I'm going to put it in pink here. So when I do that, I get the quantity, -1 quantity squared. And I'm just using the same inequality that's up here, guys. The only reason why I know is because I'm following the pattern of this. But if it's too confusing to do that, remember this is our inequality that we're testing. So -1 quantity squared times -1 minus 11 times -1 plus 3, excuse me. Okay. And then over, and then we're going to do -1 minus 5 times -1 plus 8. So -1 minus 5. So give me 1 second, guys. Times -1 plus 8. So it looks like this, right? And we're just plugging in x equals -1 and seeing if this is greater than or equal to 0. Now we get 1 times -12 times times 2, excuse me, over, and -1 minus 5 is -6, and then -1 plus 8 is 7. So we get a negative over a negative, okay, because up here obviously it's going to be negative, and then down here it's going to be negative, so this will be a positive. We know that a positive is greater than or equal to 0, so therefore we know that -3 to 0 works. So -3 to 0 is a solution, is one of the solution sets, or one of the solution intervals. So we know that all the way up here, if we go back up here, we know that -3 to 0 works. So again, this checks out, right? And we're highlighting it in green. And if I highlight the other one in red, that means that it obviously did not work. So this would be red, meaning that it did not work. And in green it did. Now we're going to do from 0 to 5. Okay, so now let's go ahead and shade from -3 to 0. Okay, so that we know that that works. And now let's do this one, from 0 to 5. So we want to test an interval. Test an x value at from 0 to 5, on 0 to 5 basically, on 0 to 5. So if we pick an x value between x equals 0 and x equals 5, we want to do, let's go ahead and state our test x value. And if we state that it's going to be, let's say 1, for example, x equals 1. And so we're going to go ahead and use that. And again, what I've been doing so far in this video, I've always been following the pattern here. We're just plugging in 1 now for this. And again, it's the same formula that we have for our inequality. So the quantity 1 squared, and then times 1 minus 11. So times 1 minus 11. Let me do this off camera really quick. Okay guys, and we want to know if it's greater than or equal to 0. So now we have 1 times negative, so 1 minus 11, so 1 squared is 1. 1 minus 11 is -10. 1 plus 3 is 4. And then over 1 minus 5 is -4. 1 plus 8 is 9. So we have a negative. Obviously this one will be negative. And then we have a negative over here as well, which we know that it's a positive. So it's going to be greater than or equal to 0. So we know that this checks out because it's greater than or equal to 0. Now we know that that the interval 0 to 5 checks out. So 0 to 5 is a solution set. So it works checks out. So on our number line, we're going to go back to our number line up here, and we're going to highlight it in green, stating that it works. So if I do that, I know that this works. Okay, and remember that at 5, it's an open circle, so that's why we're not using 5 or 0. I'm strictly using numbers that are in between because we have already stated our x-intercepts and our restrictions here. These are our intervals that we are testing, and whichever one works, we know that it'll work. But you have to test numbers between between the left number and the right number, and that's only works after you've already stated these things. So now we're going to go ahead and do our, so like I said, this one works. So now let's do from 5 to 11. And so now we're going to test 5 to 11. So test interval from, and it was what? It was, sorry guys, hold on. I'm sorry. From 5 to 11. Okay. And I forgot to put, this should be a parentheses, not a bracket. So parentheses 5 to 11. And I'm sorry guys, hold on. Okay, so again, we're going to follow the same rule here. Let's go ahead and use a number between 5 and 11. Let's say x is equal to 6. So we're going to test that out. So it's going to go the following way. The quantity 6 squared. And again, I'm just putting this in for x, replacing it for x, and I'm using these things as a guide. Again, you can use the original. It doesn't matter because it's the same thing. You're just I'm basically using the original inequality, just like I've been stating over and over. I'm using this original inequality and seeing if it works. So we're doing 6 squared and then times 6 minus 11 times 6 minus 11 times, what was it, 6 plus 3. So 6 plus 3, and we're just plugging it in, and then over, and then it's going to be 6 minus 5 times 6 plus 8. So 6 minus 5 times 6 plus 8. And so we want to know, is this greater than or equal to 0? And so here we have a 36 times negative 5 times 9 over, and we want to do, we want to go ahead and do 1 times 14. So we know that it's a negative over a positive. So this is going to be negative over positive, and negative over positive states that it's negative. So we know this cannot work because a negative is less than 0, and it does not follow this inequality. So we know that that 5 to 11 is not a solution set. Okay, so we're going to go ahead and go back up here, and we're going to go ahead and put it in red. So we know that from 5 to 11, it is not a solution set. So let's put it in red right here, stating that it really doesn't work because we just did it. So it doesn't work. Now the last one we're going to test is 11 to infinity. So this one's a little bit, actually we don't have to go all the way, but we're going to do from 11 to infinity. So this is our last test interval. Okay, and these problems are long, guys. I know these problems are really long, but the more you do them, the quicker you'll understand. So so this one, we know x is equal, so let's go ahead and do test x value. And we're going to go ahead and test x equals 12. Okay, so when we do that, we're going to just plug it in. So the quantity 12 squared, and again, I'm using the same inequality. I keep saying that because I am. I'm using the same inequality that we had at the very beginning. 12 minus 11, and then times 12 plus 3. And all you need to know if it's positive or negative. You don't have to know the exact answer unless they're talking about like a whole number or something. Like a number greater than 0, like 3, 4, 5, then yeah, you would have to know if it's a fraction or a whole number. But in this case, just know if it's positive or negative. 12 minus 5, so over 12 minus 5 times 12 plus 8. So then this becomes, so we have 144. This is a positive, this is a positive, and this is a positive. And this is a positive, and this is a positive. So we know that it's positive because it's positive over positive, which is positive. This is greater than or equal to 0. So we know that the interval 11 to infinity works. We know that works. So looking at the ones we highlighted in green and the ones we highlighted in red, those are our answers. So therefore, the solution set for this inequality, the solution set in interval notation is the following. Negative infinity to negative 8. Union, you want to make sure to use a union. Some use a comma, some use a union. A union is just like you're joining two intervals together. And then union, negative 3 to 0. Union, 0 to 5. And actually make sure you put parentheses at 5. Union 11 to infinity. And this, guys, is my final answer for this problem. So I understand this was really lengthy because these problems are really, really lengthy. So I know, and I do apologize if it took me like almost 30 minutes to do this, but it's a whole process, and I'm only explaining it, but if you do it yourself, it should take less than that. But if it does take more, just keep practicing and it'll take less time. The more you do it, the faster you'll do it. So that's going to be it for this video, guys. So this is going to be one example. So if anybody has any questions, please let me know. And thank you so much for watching. And also please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.